Welcome to Study Loop.
Let's make a substitution to evaluate the integral. Let's try u to be the numerator. That's 1 plus radical x all inside the square root. And before we differentiate, let's just square both sides. Get rid of one of those radicals. And then we can differentiate each side, use the power rule. And then now we can go ahead and write this in terms of u. So root x, well, just take this equation and solve for root x. And then multiply both sides of this equation here by the denominator. And then you get 4u, u squared minus 1 du equals dx. So that will replace dx in the integral. So we have integral on top. We see that radical up here in the numerator. That's just u by definition. So that's easy. That just becomes u. But then dx, more complicated expression. We just found this on the side. And that's 4u, and then u squared minus 1 du all over x. And x, well, we just get that by squaring both sides of this equation. So we just have u squared minus 1 squared. And here we should cancel. We see that we have u squared minus 1 on top and bottom. So we could cross that off. And we just have 1 left on bottom. We could also take out that 4. So we're left over with u squared minus 1. So let's write that. No need to factor yet because here the numerator has same degree as the denominator. They're both 2. So we should do long division here. So let me go to the side to do that. U squared over u squared is 1. Multiply. Subtract. We get a remainder of 1. This means that we can write the integral as the quotient, which was 1, plus 1 from the remainder, divided by the original denominator. Now we have this integral to deal with. You may memorize this from a table, but if not, there's no problem because we can write it as 1 over u plus 1 and then u minus 1. And then we could do partial fraction decomposition using what the author calls case 1, distinct, non-repeating linear factors. So let's go ahead and multiply both sides of this equation here by the denominator on the left. So the left side just becomes 1. The right side becomes a u plus 1, b u minus 1. Now I'm running out of room here, so let me go to the next page. 1 equals, factor out a u, and then our constant term left over. And we see, since there's no u on the left, we see that a plus b must be 0. And we see that a minus b must be 1 because that's the constant term on the left. So we have a 2 by 2 system. Let's go ahead and add those together. We get 2a equals 1. That means a is a half. And therefore b will be negative 1/2 by using the second equation here. So going back to our integral, remember we pulled out the 4. We had 1. And now we originally had 1 over u squared minus 1 here. But then we just did partial fraction decomposition. There's our a over u minus 1, and then negative 1/2 over u plus 1 du. Now we're ready to integrate. If these minus 1 and plus 1 are bothering you, feel free to do a u sub here. For the second one, you can do w equals u minus 1. For this third integral, you can do u plus 1. In either case, when we integrate, we should get, we have 4u, 2 natural log absolute value u minus 1, negative 2 natural log absolute value u plus 1. Don't forget the constant c. And then finally, use the original definition of u, the substitution, to go ahead and replace u in terms of x. So 4, and then u by definition, 1 plus radical x inside the radical, and then 2 natural log. Then we have absolute value. Technically, you can drop the absolute value here if you write it this way, because this first radical is bigger than 1, but that's not too important right now. And then we have u plus 1. Absolute value, and then plus our constant c of integration. And that will be our final answer.